In this video, we're going to take a look at using the distributive property to help us solve algebra equations. Specifically, this is going to help us solve linear equations. For those of you that are not familiar with it, linear equations simply have one variable, and the exponent on that variable, for instance down here in the example, is 1, meaning it's not there, and typically it's not listed. And so we're just going to deal with that style of equation in this. So I have just a kind of a little analogy that I use for helping me decide in what order I do things. And one is, I think about cleaning out the cupboard. And so if I'm going to clean out the cupboard, what I'm going to do is I'm going to pull everything out of the cupboard. I'm going to make a mess. I'm going to wipe out the cupboard. I'm going to restack all the dishes so that they're nice and neat. I'm going to move the dishes around as far as what I want to go where, and then I'm going to finally restack them or put them back in nice logical order. And so the problem is this fourth one doesn't relate to that, but the rest of it kind of follows that idea. You're going to make a mess if you have to. You're going to restack all of your terms, meaning you're going to combine like terms on both sides. You're going to move the variables to one side and the numbers to the other, and then you're just going to kind of clean up whatever's left. Okay, so let's just kind of go through this. Now, I'm expecting that by now you would, if you're viewing this video, that you know what the distributive property is. If not, you'll be able to pick up how to do it, but I do have another video on exactly what it is and what it says and how to use it. Okay, let's go ahead and get started. So the very first step I'm going to take is I'm going to make a mess. I'm going to distribute to eliminate all the parentheses and brackets. Sometimes you can have multiple versions of these. Okay, I'm not looking for multiple levels of distribution here. I'm just looking at a single level. So the way I do this is I circle the number and its sign up front of the parentheses or brackets. And that's just to tell me that's what I'm multiplying all the terms inside by. And I do this to both sides because I'm going to do this all at once. And then I just simply multiply it through. So I have 17, that didn't change. Negative 2 times 3 is negative 6x. And you'll notice that I said negative 2 times 3 and I'm not multiplying any x's. We'll get to that later. But right now, we're just dealing with the numbers. Negative 2 times positive 2 gives us a negative 4. I'm using the signs and the operations synonymously. And you can kind of, in this circumstance, think of them as one and the same. Whatever the sign of the answer is the operation that you need to do. Nothing changes with the equals. The 2x stayed still, so we'll just write down 2x plus 3. Now, if there's nothing out in front of the x, it means that there's 1. So 3 times 1 is positive 3x. And then a positive 3 times a negative 2 is going to give us a negative 6. So we've done that. We've made a mess. This is step 1. Step 2, we need to restack or combine like terms. So let's go ahead and change that to a light blue. And what I'm going to do is I'm going to circle all the like terms. And I do this even if I'm just using pencil. But I'll circle all my like terms. Like terms, again, they are terms that have the same letters and the same exponents on those letters. And so if I circle all my like terms to include the sign in front, I can simply read it. Now I'm not doing anything with the negative 6x. I'm going to put that first. I always put my x's first if I can. And then I'm done with that. That is the only x term on that left side. Now I have 17 minus 4 is positive 13. And those are done. And I cross those out just to let myself know I've gone ahead and combined like terms and I'm done. Equals. Now I have a 2x here and a positive 3x. 2x plus 3x is 5x. And those are gone. And I just have this negative 6 that's left. And I bring that down. All right. At this point, You can do whatever you want to move stuff around. My recommendation, because of inequalities later on, my recommendation is that when you move your variables, that you choose a side where the variable will be positive. That's only a recommendation. You can do it either way. It does not matter. But in this case, I'm going to go ahead and choose purple. Step 3, I am going to use addition and subtraction. That's what this says here. To use addition or subtraction to move things around. When I do it, I'm going to choose to try to make the variable positive. So if it ends up on the left or the right, it doesn't really matter. To do that, I notice I'm removing 6x on the left side. So I want to add 6x to undo that removal. Add 6x. I'm going to do this step 3 in 2 steps. In the first step, I'm going to eliminate, and there are reasons why I use the word eliminate versus cancel. But I'm going to eliminate the 6x on the left, and I'm going to simply combine like terms on the right, so that I have 13, if I bring this down, is equal to 11x minus 6. And now I'm going to go ahead and I'm going to add 6 to both sides. That moves the numbers to the left side. That eliminates, and I get 19 on the left is equal to 11x on the right. Now that I've done that, I have all my variable terms on one side, all my number terms on the other side. I'm going to go ahead and I'm going to, in step 4, multiply or divide to get rid of my coefficient in front of x. This 11 right here is the coefficient. It is multiplying x, and so therefore we are going to divide both sides by 11. When we do that, our 11s cancel, and I get 19 divided by 11 is equal to x. This is our answer. Now, 11s don't cancel out and go, and they just disappear. No, 11 divided by 11 is 1, and 1 times anything is that anything. That's what allows us to just simply make it look like they disappear. Okay. On my next video, I'll do an example where you're dealing with fractions, and I'll show you how you can not use fractions.